one, we have that in a school, 200 students solved a problem in a mathematics competition, the best kind of competition. Let's be honest. Their times to solve the problem were recorded and the following cumulative frequency graph was produced. So the big word here is, well, of course, cumulative frequency graph, but the key word I would say is cumulative frequency. What the heck is that? So here's our graph. I'm going to explain it in a second. And as we can see, it's only parts A and B, needing to find the median, a bunch of stuff. See? So for part A, you're going to find the median, the lower quartile, the upper quartile, the interquartile range. And for part B, we're going to find whether it's an outlier or not. Okay, and just for now, quick heads up, the outlier is associated to the interquartile range. That is the introduction to this problem. Now, before delving into the graph, let's first try to understand what they're looking for in terms of what do they mean by quartile, what do they mean by median, upper quartile, etc. So, a lot of times in statistics, these keywords help us understand our distributions better or our data better. So, the best way for me to explain median time, lower quartile, and all that stuff is using a box and whisker. Okay, and this is just for the intuition of how a box and whisker plot works. And so in a box and whisker plot, you will probably remember that it looks something like this. Boom, 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 and then I don't know, boom, boom, okay? So what's happening here? Here in this box and whisker, on your x-axis, okay, you have like your data. So if this were like, I don't know, days of the week, or actually coffees drank per week. So coffees drank per week. Okay, and you're evaluating different students, whatever, etc. So over here we can have, I don't know, 3 coffees drank per week. Here we can have, I don't know, 4, this can be 5. Here we have a big jump over to like 7, and then over here's 8. Okay, I'm just making these numbers up. The important part is the visual part. So the box and whisker plot, when it looks like this, over here you have what we call the minimum. So of the students that I'm making the survey, they at least drink 3 coffees per week. Over here's Q1, which I'll explain in a second. Over here is Q2, which is the same as the median. Okay, and then this stick over here is going to be Q3, and over here is going to be the maximum. Now, what the heck is Q1, Q2, Q3? Well, Q1 is actually going to be the lower quartile. The upper quartile is going to be Q3, and the median time, which is right down the middle, that's why it's median, Q2, let's remember it's going to be for middle, okay? Now, because Q2 is right at the middle of my data, okay, because Q2 is right at the middle of my data, I can also think about it as like you are 50% like through your data, right? In terms of lower quartile, well, look at the word quart. So when something comes in quarts, well, how many quarts do you need to make a whole? You need 4 of them. So Q1, okay, so you have 4 quartiles in order to reach like your maximum, is what I'm trying to tell you, because you need 4 quarts in order to have a whole, ¿cierto? So your Q1, because it's the first one, it's going to be 25% of your data. Upper quartile is going to be 75% of your data. Okay, and this I think is a lot friendlier to see in the box and whisker. That is why I drew it. So basically from your minimum, and this is the key idea, okay, from the minimum to Q1, you have 25% of your data. From Q1 to Q2, you also have 25% of your data. From Q2 to Q3, you also have 25% of your data. And from Q3 to max, you also have 25% of your data. The point is the following. If you're looking at the upper quartile range, which is right here, well, in order to reach it, you need to have passed through this 25, this 25, this 25. You add all of those together, you get that 75%. Okay, so a lot of this has to do with sort of like proportions in terms of where you're standing in your data. Quartiles, think about them as percents. Okay, one quartile is going to be 25%. Depending on the quartile that we're talking about, it can be 25, it can be 50, it can be 75. Okay, so With that being said, and understanding the context a little bit better, we can now jump into part A. So, we have the intuition of the box and whisker, how it looks visually. We're going to employ the same idea over to the cumulative frequency graph. Okay, so down below, and this is the main difference, down below, okay, like the first student, the second student is somewhere in between in here. Okay, you're not sure where. You actually, it's hard to know. See, but you know that the first couple students are, I mean, yeah, the first couple students would be around here. See, if you put them in order, blah blah blah, etc. In the cumulative frequency, it is much more detailed. Okay, because here all you know is that the first 25% are there, but over here you can actually count them one by one. The way cumulative frequency works is that it accumulates itself. That's why it's cumulative frequency. And so here they say it's 200 students, right? And so where are the 200 students here? Right there. And so 200 students, as you can see, if you draw a straight line over there, you reach the end of your data. Ah, look at that. And so you can actually count each student. I mean, you can literally say, yo, student number 25, how much time did he take to solve this problem in a mathematics competition? And so student number 25, okay, notice the language I'm using. Student number 25 spent, how much time? They spent 25. Spent 25 seconds solving a problem in a mathematics competition. And this is very different, and this is the main idea. This is like the hard part I need you to catch, okay? This is student number 25. I'm sorry, this is student number 25, see? But what if I'm asking for this student at quartile 1, which is actually what they're asking for this part here, see? They want you to use the graph to find the lower quartile. In other words, they're trying to ask for the person standing at Q1, which is the person that is 25% through your data. Okay, 25% through your data. What is that? See, so the student at Q1 is the student which is in the first 25% of your data, but right on that 25%. See? And so if you have 200 students, well, what is 25% of 200? Essentially, all you have to do is take 200 and multiply by 25%. Now, it's kind of hard to multiply by a percent here, so what we do is that we pass from percent to decimal. And this is going to be 200 times 0.25, which will give me 50. So, with that information here, I can identify that the student at Q1, which is the student in the first 25% of your data, is student number 50. So at student number 50, we have our Q1 because student number 50 is on 25% of my data because 200 times 25% gives me that 50. Now, I might have gone a little bit quick there. Let me explain how the 0.25 appeared in the first place. You guys, when you are passing from percent to decimal, I feel like it's more intuitive. I put it with a couple examples. See, so I highly suggest you remember these three values: 100%, 50%, and 5%. If you remember how to pass these percents to a decimal, you're gonna catch like the pattern that goes behind it. See, so the first important thing is that 100% in decimals is going to be 1.00. 50% is going to be 0.50, while 5% is 0.05. So what I suggest is memorize like this small sort of table for passing from percent to decimal, and then you can use this for any example. See, if you're ever looking for, I don't know, 27%, you just follow the pattern of, okay, basically you just gotta put the decimal 2 points in front, see? So if here you have the decimal for 50%, you're gonna go 1, 2, and you end up there, see? So this would be 0.27. If you're ever looking for 0.2%, this is a little bit trickier, but eventually, if you think about it for long enough, you will discover it's 0.0002. Let me just double check that real quick. Da, da, da. So that's 2%. Sorry, it would be, it's a little bit tricky, it happens to all of us, 0.002. See? So basically, memorizing this table can really help you to understand how to pass from a percent to a decimal. The other thing I can tell you is that technically you just divide by 100. See, if you take any of these values, for example, the 100, and you divide by 100, you end up with 1. If you take the 50 and you divide by 100, there you end up with the decimal, 0.5, same as 0.50. If you take the 5% and divide by 100, there you end up with the 0.05 as a decimal. So here are the 3 examples of this table. You can also memorize that you divide by 100. Anyways, that was just a little bit of blah blah because I know some people probably are confused on how this happened. Now you know. And from here, it should be smooth sailing because now that we identified how to understand these sort of percents and proportions, we know that 50 students is 25% of my data. So over here, and just to like, I guess, remember, I suppose, I can put that this is Q1, okay? So this is Q1, and Q1 is going to be 32. On the other hand, and because we need everything, I'm just going to fill it in. The median time is going to be my Q2, as I mentioned here, right? It's right the middle of my data. If I have 200 students, the student at the middle is student number 100. So over here, I have student number 100. Then I go down from there, and this will be my Q2, which is the same as the median. And the value of that is 38. And then Q3, well, let's find out. So Q3 would have to be 200 because I have 200 students times 75%, right? So 200 times 75% is the same as 200 converting to a decimal times 0.75. See? So that will give me 0.75, bada bing, bada boom, 150. All right, cool. So at 150, we have our boom. We have the value we needed. So here we have Q3 at 150 is going to be at 42. See? So using all of this, you can quickly answer that the median time has to be 38, my Q2. The lower quartile has to be 32. And the upper quartile has to be 42, right? So this, like once you understand that, you can read any graph. Okay, so the main ideas which I think are important is on the one hand, be careful with your total. Here we had 200 students, and so for finding 25% of that, you got to do 200 times 25%. A lot of times, instead of 200 students, you have 100. So it's much easier because 25% of 100 is student number 25. It's very straightforward when you have 100 as a total. But when you have 200 as a total, 300, 400, or something that's not 100 basically, 25% of it gets a little bit trickier. Okay, so keep in mind the magic trick. Take that 200, multiply by your percent, know how to pass from percents to decimals. All right? Bada bim, bada boom. So, that is for parts A, I, double I, and triple I. And for part A, single I with a single V, part A, part 4, we need the interquartile range. So, you guys, and here's another quick tip that I think would really help for your IB exam. So, the day of the test, and I know I say this a lot, but I just can't hammer it into your brain enough. The day of the test, you will be walking in with a brain, a pen, a pencil, 2 years of experience of this thing called IB, 2 hours of sleep, your graphing calculator, and da 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 da, your formula booklet. You guys, the formula booklet is going to save you. I promise you it's going to save you. But do not make the mistake of saying, I have the formula booklet, I have all the formulas, I'm good to go. That is not good enough. Okay, you need to know what is inside the formula booklet. You need to be able to identify, and this is why I talk about all these buzzwords, all these keywords that are like the essential concepts of the exercises, and they might be in your formula booklet. For example, in this exercise, yes, we talked about cumulative frequency. That is not in your formula booklet. So sad. Yes, we talked about median time, lower quartile, and all these quartiles, but that is not in your formula booklet. So sad. But the interquartile range is in your formula booklet. And you might not know exactly what it is or how it works and this or that, but this is the kind of concept or thing that you should be able to read and say, I'm pretty sure that's in my formula booklet. I'm not entirely sure, but let's double check. See? So you should be able to read certain words and certain concepts and identify them as they exist in here. That is the kind of stuff and small detail that saves you a lot of time the day of the test. Because if you don't know what's inside your formula booklet, maybe you would have spent time trying to find the lower quartile. Maybe you would have spent time trying to find the upper quartile. Well, instead, you can know what's in it, know what's not, know when to use it, know when not to. And as I said, the interquartile range is essential for the outlier. So it's good to know it's in it. See? And also, it's a classic. It's absolutely a classic for them to ask for an outlier. Know how it works. See? So, in the formula booklet, it helps you for the interquartile range. It does not help you for the outlier. So, the interquartile range, before anything, let's talk about range. See? So, there's two types of like ranges you can have. So, you have the range, which is a classic in statistics. The range is just going to be max minus min, while the interquartile range, well, it's the range, but of the quartiles. So, the interquartile range is going to be the upper minus the lower. See? And this I know because I've done a lot of different videos and exercises involving something like this, but we can go to the formula booklet. Once we identify the buzzword of interquartile range, we can look for it. It will be in statistics and probability, page 9. So we go to page 9. Doop-de-doo. Lo and behold, it's the first one. Interquartile range, Q3 minus Q1. So if you ever forget it, it's in your formula booklet, but it is the sort of concept that you should read and should know. It's somewhere in there. See? So the interquartile range is just Q3 minus Q1. So you will be doing 42 minus 38. Oh, sorry. Q2 minus 32, my bad. So the IQR has to equal 10. See? Just so that we're on the same page, here are the answers. Looks pretty good to me. 38, 32, 42, 10. 38, 32, 42, 10. See? So, part A is complete. Then they tell us that our good old friend Cedric took 14 seconds to solve the problem. And we need to determine whether Cedric's time is an outlier. And notice, this is worth 3 points, and I would say that it's extremely easy 3 points. See? All you need to know for an outlier, and this is an introduction I will give you for now, all you need to know for an outlier is the interquartile range. So that's the first thing I need to explain for the procedure for an outlier. First, get the interquartile range. Secondly, we need to, depending on where the outlier is, apply the following formula. See? And the formula is extremely specific. See? You have an upper bound and a lower bound. Okay? Now, what I should have explained earlier, and I will do now, okay, is that an outlier, like what is an outlier? See, I should have gone through that first. Sorry. So, an outlier is something in your data that like is a little too far out. See? So imagine we go back to the coffee example. See? And one of my biggest values was like 8 coffees. But one of your partners, whatever, drinks 20 coffees per week. You know, we all know someone like that. So someone out there is drinking 20 coffees per week. Is that an outlier or not? Is that so far out that like it doesn't align with your data? Or also maybe someone that drinks 0 coffees per week. That can also be an outlier. And so that is why I put upper bound and lower bound. They are outliers as much as for students solving this problem way too fast and students taking way too long to solve this problem. See? So that is why outliers have upper bounds and lower bounds, whether they are like way above the expected or way below the expected. Okay? So our good old friend Cedric took 14 seconds. And so 14 seconds, as you can see, is right there. Remember that on the bottom is seconds. And so Cedric looks like is, I mean, this isn't the first student, but it's one of the first students, right? Solve the problem in 14 seconds. And so is this an outlier or not? A lot of people do the mistake, and I will show you now. See, a lot of people do the mistake, and here's Cedric, by the way. Yeah. A lot of people do the mistake that they say, but this point of information is within my data, so why would it be an outlier? Guys, that's the thing. Within your data, you can have outliers. You got to identify them in order to get rid of them, or at the very least, acknowledge them. Okay? So, how do you identify which number is an outlier or not? Imagine I made this much easier for you. Write that on the bottom. We have time and seconds. See? Imagine I just invented as a rule. See? Imagine I just invented 20 or lower will be considered an outlier, and 50 or upper will also be identified as an outlier. See? Then it's very easy because you say, okay, so all of these guys are outliers, and all of these guys are outliers. It's much easier when you do that. See? Well, when you do that, you are using the lower bound, which is the guy you put right there, and the upper bound, which is the guy I put up here. See? I mean, more on the right, at 50 and at 20. Now, that was completely arbitrary. I just made it up on the spot. There is an argument for which one should be your lower bound and which one should be your upper bound, which is the formula that I'm about to show you. So how do you define the upper bound? How do you define the lower bound? What you actually do, and let me just double check because it is very specific. Exactly, you see. Yeah, we're good. Yeah, so basically, okay, basically what you will be doing is that for the upper bound, see, you want to see if it's up and beyond. So you will be doing Q3 because it is for the upper bound, the upper quartile. You will be using Q3, upper, 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 Q3, Q3 plus 1.5 times the IQR. While for the lower bound, you will be using lower bound, lower quartile, the Q1, Q1, and because you're talking about below, you'll be doing Q1 minus 1.5 times IQR. So those are the two key formulas for identifying these lower and upper bounds. If I apply it up for the upper bound, you end up with 42 plus 1.5 times IQR, which we said was 10. So that ends up as 42 plus 15, if I'm not mistaken. Let me just check my work. Yeah, so the upper bound ends up as 57, while the lower bound will be Q1, which we said was 32, minus 1.5 times the IQR, which we said was 10. So it's going to be 32 minus 15. Let me just check my work anyways. Yeah, there you go, 17. See? So basically, these pink lines that I put for lower and upper bound, it was just to explain the idea, ¿cierto? But your argument for which one is your lower bound was using the formula. And so your lower and upper bound will be at, I'll put it in red. Actually, I'll put it in light green. So the upper bound is 57. So at 57, which is 57, 55, 56, 57. So at 57, which is right there. So here you have 57. This will be the upper bound, right? So anyone to the right of this is considered an outlier. So student number 200 is an outlier. Student number like 190 is also an outlier. Okay, makes sense. See? Well, for the lower bound, you have 17. So 17 over here is just around 19, 18, 17. So here I'm going to put 17, 19, 8, wait, 19, 18, 17. There is my lower bound. See? So anyone to the right of, sorry, anyone to the left of the lower bound is an outlier, while anyone to the right of the upper bound is an outlier. Visually, it makes sense. And so is Cedric to the left of my lower bound? Yes, he is. And so Cedric would be defined as an outlier. Now, careful. This is worth 3 points, so you gotta answer carefully. See? One of your points is given to you by using the formula. See? And so that is 1 point, right? Using the formula. The other point is going to be if you mention that Cedric's time is an outlier because they are below my lower bound. See? And then the last point is going to be actually using the mathematical argument, which is basically Cedric's time 14 is less than the lower bound 17. See? And if you look at the answer key over here, you can see that you have one method point, which is the one I mentioned by using the formula. Ah, well, the other point I was mistaking is actually applying the formula. And then this right here, see, this is worth 1 point. So that is 1 point. This is another point, actually, this here, and this is another point, okay? So those are your 3 points. I mentioned the points thing because it's important to understand how they evaluate you, of course. But more importantly, notice how many points these exercises are worth. That can be a hint of how much you should answer or not. Okay? Because this is worth 3 points, one of the points is that you know the formula, the other one is actually using it well, and the last one is concluding. And this is essential for almost any exercise. See? For example, let me find like this is a good one. So here we just state the conclusion of the test. Okay, it's a chi-squared test. See, and so because it's worth 2 points, I can assure you one of the points is your justification, and the other point is the conclusion. Because you might know the justification, but you might not understand the conclusion. See, so this is for exercise 6. This is just to explain like a test taking strategy. See, so over here, this is your justification, right? That or that is your justification, but you need to be able to interpret it. See, you need to be able to say, does this mean you reject? Or does it mean that you fail to reject, right? That is the sort of stuff that is important to know. That is the sort of stuff that they're testing you whenever you see that these exercises have more than 1 point behind it. See? So be very aware of that. It can be a big hint for how you should move forward with a lot of these exercises. So that is enough blah blah for me. A little bit of a longer video, but I think it was worth explaining some of this stuff. So take it easy. Just so you know, no one completes an exercise in 14 seconds unless it's a very simple one, so don't feel bad. Yeah, math is hard. See? Take it easy, guys. I'm here to help. I hope it helped. See you around.